Today we're going to be talking about place value. The value of the position of a digit is what place value is defined as. Depending on where the digit is located in the number will depend on what the value of the digit is within the number. Digits are given place value depending on where they're located at in the number. If they are in the ones position, they will be worth just 1. If they are in the tens position, they're actually worth 10. So if we had a 9 in the tens position, it would be worth 9 tens, which equals 90. If we have it in the hundreds position, it's going to be worth 9 hundreds, which would actually be worth 900. Again, you can keep counting up to the different place values. If it was in the millions place, and I had 9 millions, then I would write it in standard form with 9, 000, 000. Again, you can go ahead and write the different numbers into the different positions so you can determine what is the place value. Let's practice using 5,498. When I begin, I know that every number has a decimal at the very end, even if it's not there. If there are no decimal numbers, it's going to be invisible, but you can put it there. I know that the first number to the left of the decimal is going to be in the ones position, so I know that that's going to be worth 8 ones. The next position to the left is going to be the tens, so I know that I would have 9 tens. The 4 is going to be in the hundreds position, so that would be 400. And I have the 5, which is going to be in the thousands position, and that would be worth 5,000. Now I could write this number out in expanded form. I'm going to start with the largest number, and that's going to be in the thousands place. I know that 5 thousands would be written 5, 000. In the hundreds, I have a 4. That would be 400, so 400. And in the tens, I have 9 tens, which would be 90. And in the ones, I have just 8 ones. With expanded form, you could then add it up, and you would end up getting 8, 9, 4, 5, or 5,498. Remember to include your comma after you count back 3 digits, so it's in between the 5 and the 4. Let's practice with 72,981,212. Remember, I have that invisible decimal point to the side, and I know that the first digit to the left is going to be the ones. The next digit is going to be the tens. The third digit to the left is going to be the hundreds. The fourth digit to the left is going to be the thousands. The fifth digit, or the 8, is going to be the 10,000s. The sixth digit is going to be the 100,000s. The 2 is in the 7th place from the left, which is going to be the millions. Then the 8th place has a 7 in it, which would be the 10 millions. I can now use the place value in order to figure out how much each digit is worth, and I can write that out by using expanded form. I'm going to start with the largest number, which is going to be in the 10 millions, and I know that I have a 7 in the 10 millions. The 7 stays the same, but everything else to the right of the 7 turns to zeros. So the 2 is a 0, then I have a comma, the 9's a 0, the 8's a 0, the 1's a 0, comma, the 2's a 0, the 1's a 0, a 2's a 0. So looking at that, the 7 is worth 70 million because it's 7 10 millions. The 2 is in the millions place, so it is a 2, and everything to the right becomes zeros. You also know that 2 millions is worth 2 million. The 9 is in the hundred thousands place, so it's going to be 9, and then everything else is changing to zeros because it's going to be 900,000. Continue with this pattern, and you have 80,000 because it's 8 10,000s. And then you have 1,000. You have 200. You have 10, and then you have 2. If I added this up, again I would be able to get 72,981,212. Let's try our last example with 16,891. Remember, you have your invisible decimal to the right. Then you can write in your place value so you can determine what the digits are worth. Now that I know where each place value and the digits align, I can determine how much each one's worth. I'm going to start with my largest number, which is going to be the 1 in the 10,000s place. And if it's 1 10,000, that's going to be worth 10,000. I have 6 thousands, which would be 6,000. I have 800s, which would be 800. I have 9 tens, which would be 90, and I have 1 1. I'm going to go ahead and add that up, and I would end up getting 16,891. By determining the place value of each digit, I was easily able to understand expanded form. I was able to determine how much each digit was worth by figuring out exactly where it stood in the number. Remember, if there's no decimal, you're going to want to draw it in because it's automatically there to the right of every number.